This problem will be a good practice for not only handling linked lists, but also variables that point to certain pieces of data. So the idea is that we're given a linked list and an integer n, and we want to remove the nth node from the end of the linked list, and then return that linked list, right? So in the example on the left, we have that we want to return the second to last node in the linked list, and so we want to traverse to the third node and then cut out the connection to the fourth and then just connect straight to the fifth. Okay, so first we'll start with our trivial case by saying if not head or not head.next. Head.next, right? Just return, there's nothing to return, right? So we're done. Next we have that m equals n and then n equals 0, and then we want to say h equals head. So just to pause for a second, the reason I'm pointing m to n here is a habit that I like to use, which is basically using n as my main variable to traverse things. It's something I've gotten really used to. You don't have to get used to it, but it's something I find very convenient when I'm from problem to problem. Next, we need the length of this linked list to find out how many nodes are in it, right? So we'll say while h, that's the thing that's pointing to the head of the linked list, n plus equals 1. H equals h dot next. So what will happen is h will start at 1, and when we say h is h dot next, it'll go to 2, 3, 4, and so on. And then while we're doing that, we're incrementing n to find the length of that linked list. All right, and then we want to say, well, there's this like kind of basic edge case that says if they're equal, m and n, if m and n are equal, then you want to remove the first node. Remove first node, right? Because it's the, so suppose this says that n is 5 on the left, it's the fifth node from the end of the list. So 1, 2, 3, 4, 5, right? So if they're equal, so if m is n, head equals head.next, right? And then we just want to return head. Just return head, right? Because we're getting rid of the first node, and that's all we need to do. Then of course we have the general case. Our general case says h equals head. And this time, however, we're going to say for I in range n minus m minus 1. N minus m minus 1. Remember, n is the length of the linked list. M is the mth node from the end that we want to remove, and then we say minus 1 because we want to stop right before that node that we want to remove. So we want to stop right before the 4 on example 1 so that we can sever that connection to the 4 and then skip over and connect to the 5, so 3 to 5. H equals h dot next, right? And then when we get to that node, it could be that we're at the second to the last node. It could be that if this was n equals 4 on the left, we'll say, okay, we need to handle that. If second to last node, we say if not h dot next, right? So if we don't have a skip node, right, so the second node beyond the one that you're standing at, then we want to say h dot next is none. So we remove basically the last node in the linked list, and then we say, okay, well, we're done. Return head. Right? Return head. Now for the rest of them, we want to say h dot next equals h dot next. All right, to make that skip. Then we return head. Run. Accepted. Submit. Outstanding.